Welcome back everyone. Today we will do exercise 1.5 question number 2. Simplify each of the following expressions. First part is 3 plus root 3 into 2 plus root 2. Now how to simplify it? See, the question is 3 plus root 3 into 2 plus root 2. Now take the first bracket and the first term is 3. So the first term of first bracket will multiply with second bracket, full second bracket, and second term of first bracket will again multiply with the second bracket. See how? 3 into 2 plus root 2 plus second term is root 3 into second bracket is 2 plus root 2. Now open the bracket. 3 2s are 6. 3 into root 2. 3 is rational and root 2 is irrational, so they cannot be multiplied. So it will be written as 3 root 2 plus, again 2 is rational and root 3 is irrational, so it will be written as 2 root 3. Always write rational in front and afterward irrational. 2 root 3 plus root 3 into root 2. Root 3 into root 2 can be multiplied and it will become root 6. Now you can observe in these two terms they are not like. Here irrational term is root 2 and here irrational term is root 3. So they cannot be added. So, and this is rational, this is irrational. And these three irrationals are not like, so nothing will be added. So this is the answer of first part. Second part is 3 plus root 3 into 3 minus root 3. Now if you recall it with the this identity that you have previously done in 8th class, a plus b, a plus b. See, a is same in both the brackets and b is same in both the brackets, and they have opposite signs. Here it is a plus b and here it is a minus b. So if you recall it, a plus b into a minus b is a square minus b square. So here a is 3 and b is root 3. So what, put the value of a and b in this identity. So a square is 3 square is 9 and root 3 square is, we have to multiply root 3 2 times. Root 3 into root 3 is root 9 and root 9 is a perfect square of 3. So 9 minus 3 is 6. So answer of second part is 6. Next part is root 5 plus root 2 whole square. So if you can write it like root 5 will be written as a and root 2 is b. So you can, now you can compare it with this question. This part will be compared with this identity a plus b whole square. So here we are using identity a plus b whole square. If you recall it, a plus b whole square is a square plus b square plus 2ab. So here a is root 5 and b is root 2. Now put the value of a as root 5 and b as root 2 in this identity. So we get root 5 square plus root 2 square plus 2ab. So 2 into root 5 into root 2. Again, root 5 square means root 5 into root 5. Root 5 into root 5 gives us 5 because root 5 into root 5 is root 25 and square root of 25 is 5. Plus root 2 square. Root 2 into root 2 is root 4 and root 4 square root of square root of 4 is 2. Then plus 2, root 5 into root 2 is root 10. So 5 plus 2 is 7. They can be added. Both are rational. They can be added. 7 plus 2 root 10. Now they cannot be added because second term is rational and irrational. So they cannot be multiplied. So answer is 7 plus 2 root 10. 7 and 2 can also not be added because 2 has an irrational term. 7 does not have that irrational term. So answer is 7 plus 2 root 10. So this is third part. Now come to fourth part, root 5 minus root 2 into root 5 plus root 2. Again, you can compare it with the same identity a minus b and a plus b. Why a minus b, a plus b? Because you can observe that here in both the brackets first term is same and second term is same. So this is a and this is b. So a minus b, a plus b is a square minus b square. So taking a as root 5 and b as root 2, a square minus b square. Root 5 square is 5 and root 2 square is 2. So 5 minus 2 is 3. So this is the answer of fourth part. Now come to question number 3. Recall, pi is defined as the ratio of circumference of a circle to its diameter. That is, pi is equal to C upon D. Circumference of circle upon diameter. This seems to contradict the fact that pi is irrational. Now the question is, if pi is written as circumference upon diameter, so this is of the form numerator upon denominator, p upon q form, then it should be rational. Then why pi is irrational? This seems to contradict. So this statement is contradicting the fact that pi is irrational. How will you resolve this contradiction? Now the contradiction is, if pi is C upon D, which is of the form P upon Q, then it should be rational. Then why we always say that pi is irrational? So we have to resolve this contradiction. Now how to do it? See, pi is C upon D, ratio of circumference upon diameter, and we know circumference of circle is 2 pi r and diameter is 2r. So if we cancel out, we get pi. So there is no contradiction. How we are resolving this contradiction? There is no contradiction. Remember that when we measure a length, suppose this is a circle and this is the circumference of circle. This is circumference of circle. So if we measure the length of this circumference with a scale or any other instrument like thread, etc., we only get an approximate rational value. We will not get an exact value. We always get a approximate rational value. So we may not realize that either C or D is irrational. Either it is a case of diameter also. If we do not know the length of diameter, so we will not, it is not sure that we will get an exact value of diameter. So we may get an approximate value of diameter. So we may not realize either C or D is irrational. So we do not get whether C is irrational or D is irrational. If C is irrational and D is rational, then irrational upon rational, we again get an irrational number. Or if C is rational and D is irrational, and rational upon irrational always give us irrational number. In both the cases, we get pi as an irrational number. So therefore pi is irrational number. So this completes your question number 3. Now come to question number 4. Represent root 9.3 on the number line. Earlier we have done root 2 on the number line, root 5 on the number line. So today I am going to tell you how to represent a real number. 9.3 is a real number. So how to represent any real number in square root on the number line. Earlier root 2 is a positive integer. That topic was related to how to represent positive integers, square root of positive integers on number line. Now this question is how to represent the square root of any real number on the number line. So see, this is the procedure. First of all, you draw one line segment, draw one line and mark point A. Then suppose we have to make, the question was represent root 9.3 on the number line. So now what you have to do, first of all, mark 9.3. See, this is 9.3. This is 9.3 and mark it here O. So this AO is 9.3 centimeter. Now what you have to do is take 1 centimeter more, 1 unit or 1 centimeter more than, this is B. 1 unit, 1 centimeter more than 9.3. So take AB as 10.3 centimeter. Right? Now first step is take AO 9.3. You have to represent root 9.3. So take AO 9.3 centimeter. Then take 1 centimeter more than 9.3. So this AB is 10.3 now. Now what you have to do is take more than half of this line AB and draw perpendicular bisector of this line AB like this. So another step is draw the perpendicular bisector of this line AB, not AO, AB. We have to make perpendicular bisector of AB and mark this point as M. Now, keeping the center as M and radius equal to MA or MB, in either way you can take. Draw a semicircle. Like this. Now what you have to do, after drawing the semicircle, draw 90-degree angle at point O. Draw ON perpendicular to AB and mark point P. This perpendicular will intersect this semicircle at point P. So this OP is root 9.3. But we have to represent it on number line. Now taking O as center and radius as OP, just drag this length on the number line here and mark this point as Q. So this is, so O we are taking as 0 and Q as 9.3. So therefore OQ represents under root 9.3. So these are the steps. Just see, step 1 is on a line mark a point A. So first of all take a line and mark point A. Take AO 9.3 units. So another step is take AO equal to 9.3 centimeter or 9.3 units. Second step is mark a point B. Now we have to mark a point B on the line OA, on the same line OA, such that OB is 1 unit. So we have to take OB 1 centimeter or 1 unit more than AO. Now third step is using ruler and compass, draw perpendicular bisector of AB. The next step was we have drawn perpendicular bisector of this line AB, not AO, AB. So taking more than half of AB and draw perpendicular bisector of AB and name it as M. So this point is the perpendicular bisector. The midpoint of line AB is M. Now with center M, taking center as M and radius MA or MB, draw a semicircle. So marking this as, taking this as center and radius MA or MB, draw a semicircle. Draw perpendicular ON at O. The next step was draw perpendicular 90-degree angle at O. ON perpendicular to AB, which intersect the semicircle in P. So this perpendicular will intersect the semicircle at point P. Then OP is 9.3 units. Now to represent 9.3 on the number line, draw an arc with center O. Now if we want to represent this root 9.3 on number line, what we have to do, we have to take again center as O and radius as OP and just drag this distance on number line, and which cut the line OB in Q. So it will intersect the line at point Q. So thus if O represents 0, so if O is 0 on the number line, then Q will represent root 9.3. So OQ represents root 9.3 on it. So this is how we can represent under root 9.3 on the number line. Thank you.